In this tutorial, we're discussing how to solve an acceleration problem, and more specifically, how to choose the appropriate equation when dealing with word problems. For this question here, we have Marissa's car accelerates at a rate of 2.6 meters per second squared. How long does it take for Marissa's car to accelerate from the speed of 25 meters per second to a speed of 32 meters per second? So our first step is to write down what we are given. And I see that we are given that the acceleration is 2.6 meters per second squared. Now you need to write down A equals. Don't just write down 2.6, but write down A equals 2.6 meters per second squared. It'll help us with finding our equation later on. I also see that she goes from a speed of 25 meters per second. So V is speed. And she goes to a speed of 32 meters per second. So we have two of these speeds. We need to distinguish between them. The word from lets us know that that is her beginning or initial speed. So we'll designate that it's the initial using an I, VI. It also says it goes to a speed of 32 meters per second. So the word to lets us know that that is the final. And we'll designate that as an F for a subscript as our final speed. Next step is to write down what we're trying to find. It asks how long. The words how long tell us that we're looking for time. How far would be distance. How fast would be a speed. In this case, it's how long, so we're looking for time. Next step is to find an equation. So when finding an equation, of course, it has to have what we're trying to find. It has to have time in it. And the first three have time in it, but the fourth does not. So we cannot use that for this problem. In order to use an equation, in order to solve a mathematical equation, we can only have one variable. So we need to know everything else in that equation to use it. Let's look at the first equation. We need to know VF, which we do, it's 32. We need to know VI, which we do, it's 25. And we need to know A, which we do, and that is 2.6. You can see if we go back, it's real easy to see which ones we know because we wrote the letters down. So when we go to our equations, it's real quick to figure out which ones we have and which ones we don't. So equation number one is our equation because it has everything except for time. In the second equation, we see that although it has acceleration and initial velocity, which we do know, it does not have, we do not know distance, and so that equation cannot be used. Same thing for the third equation. Although we know the initial velocity and final velocity, we do not know the distance, and so we cannot use that equation either. So now that we have our equation, let's write that down. VF equals VI plus A delta T. So let's section this off, make it organized. We know our givens are up here. We have our find down here. We have our equation. And now let's write the numbers in that equation. So we have 32 meters per second equals 25 meters per second plus 2.6 meters per second squared times our time, which is what we're trying to find. Solving for this, we want to get rid of anything added or subtracted to our variable first. So here's our variable on the right-hand side. Let's get rid of the 25 on both sides. So we're left with 7 meters per second is equal to 2.6 meters per second squared times our time. And now we can get rid of the 2.6 multiplied to the time. To get rid of something that's multiplied, we divide. So divide each side by 2.6 meters per second squared. And we have that our time is 2.69. Our units, we see up here, we've been using seconds for time. So our units for time is seconds. Put a box around our answer, circle it, so it's easy to find, and we are finished.